Okay, we've looked at approximating areas under curves or integrals like this integral of f of x from x is a to x is b, with a number of different rules, two rules, the trapezoidal rule and Simpson's rule. So the idea here is to split our region we want to work out the area of, split it into strips. And the number of strips will determine what that integral is and maybe even what the error is. So remember, this is only an approximation. There will be an error compared to the actual integral under that curve. If we split into just two strips, a rather coarse approximation, then I could work out this integral using these two strips, whether I use trapezoidal or Simpson's, and let's call that integral I2, so the integral using two strips. Now that will have an error. The error I'm going to call E2. That's the error of this approximation compared to the actual integration. I could double the number of strips. I could now use 4 strips. I'd work out this integration. I'd get a I4, and the error would be E4. Now we hope that the error in this case with 4 strips would be less than the error here. So we would hope that E4 is less than E2. And I could keep going. I could double the number of strips again. I get 8 strips, 16 strips, 32 strips, etc. Okay, well, we can actually work out a relationship between these errors as we double the number of strips. For the trapezoidal rule, it turns out that the error using 2n strips, so that's twice n strips, is approximately equal to, not the error using n strips, but a quarter of that error. So this looks great. We're quartering the error every time we use double the amount of strips. And in fact, the actual integral, the real integral, if we could work this out analytically, the real integral can also be approximated. This is approximately the integral using 2n strips plus a third of the difference between 2n and n. So for a really good approximation for our actual integral, I work out the integral using n strips. I work out using 2n strips. I take this difference, take a third, and add that onto the integral using 2n strips. We can do exactly the same for Simpson's rule. And in fact, we have very similar approximations for these errors. For Simpson's rule, if I double the number of strips, then this is approximately the error for when I double the number of strips is actually 1/16 of the error with just n strips. So Simpson's rule is a much more accurate method. Every time I double the number of strips, I reduce the error by a factor of 16. And similarly, I can approximate the actual value of the integral using this more accurate integration approximation with 2n strips, and I have to add on 1/15 of the difference between using 2n strips and n strips. Okay, so there's a lot of mathematics behind these results, but these are really useful to see the accuracy of the trapezoidal and the Simpson's rule. Simpson's rule is a bit more complicated, but it gives you a much lower error than the trapezoidal rule.